In this demo I will examine a reference type that is very widely used, the string. I'll talk about a special part in memory called the string constant pool and what it means to intern a string. Just one class containing the method for this demo. Now, in the Java API, strings are defined as classes, and thus when instantiated, the objects are created on the heap. Creating a string can be carried out using two syntaxes. The first one by using a shorthand syntax allowing you to directly assign a string literal to the reference variable, as demonstrated here with variables apple1 and apple2 that are assigned the same string literal apple. The second syntax involves using the new keyword, as demonstrated here with apple3, which is passed string literal apple, but this time via the constructor. Important to note is that different scenarios are carried out behind the scenes when using the string literal syntax or when using new. In the last two lines, I print out some comparisons. If you're new to Java and to the string class, maybe pause the video here and try to predict the result of the printouts. Let's find out in the memory layout. I start by setting up the stack frame for the main method with its arguments parameter. Then the declaration of the first string. Apple1 is of type string and assigned with literal apple. Apple1 is declared on the stack, and when this happens, the assignment with the string literal, the JVM looks for the occurrence of apple in a special area in the heap called the string constant pool. Since string literal apple is used for the first time in our example at this stage, nothing will be found in the pool, and this results in a new string object containing apple to be added in the pool. Its reference is returned to apple1. The procedure by the JVM of adding a string object to the pool is called interning a string. What happens when we declare apple2? Since this variable is assigned with the same string literal apple, again the JVM looks for the occurrence of apple in the string constant pool. This time, however, a string object will be found, and so a reference to this object is returned to apple2. This results in both apple1 and apple2 to refer to the same object. So we see that the JVM optimizes the amount of memory allocated for string literals. For each literal string in the pool, only one copy is stored. Then apple3 is declared and initialized using the new keyword. This is what we can call the normal instantiation of an object on the heap, and apple3 refers to that new object. Now, what is printed when we compare apple1 and apple2? Easy. Look in the current stack frame for the values that both variables hold, and since they refer to the same object, the result yields true. What is printed out when comparing apple2 and apple3? Again, look in the stack frame. You see already here different values, and that is because both refer to a different object. This results in false. Now, as the title of the presentation suggests, this is a naive view. I mean, why would apple3 contain string literal apple again, since it is already held by another object in the string constant pool? And it's true, we have two different objects, but there is already an optimization going on that isn't reflected here. We need to adapt it somehow. In order to understand how the objects really look like in memory, we need to look for the definition of the string class in the API and debug some code. Let's do that. Looking at the definition of string, here I'm using Java 11, we note the presence of data member value. It is defined as an array of bytes, and that is actually where the string literals are stored. It is used for character storage. Now, two more data members are defined, coder and hash, but I'll focus on value only, as the others are irrelevant for this demo. if we were to debug our small program and examine the stack frame of main, here is what it will look like in Eclipse. Now, Eclipse doesn't show addresses for reference variables the way I do in my presentations. Instead, objects referred to are given a unique ID. Here, I expanded the stack frame just before the print statements. First, note the structure of Apple 1, which refers to string object with ID 23. The object has actually 3 data members, but we focus on the array value. And here we see the separate characters for uppercase A, lowercase p, etc. This is our apple. This is our string literal. The value object has an ID of 29. Apple 2 refers to the same apple object with ID 23. And so with a value of ID 29, both Apple 1 and Apple 2 refer to the same object. And now comes the important thing. Apple 3 refers to a different Apple object, ID 28, but note what value refers to, ID 29. So Apple 3 refers to the same array of characters as the intern string Apple 1. Let me demonstrate this in a debug session. So here I'll debug the program in Eclipse. I set a breakpoint at line 8 and I start the debug session. Execution stops at the breakpoint, and let's have a look at our stack frame, which is displayed in Eclipse in the variables window. So we note the arguments parameter, then Apple 1. Here the IDs have different values because I start a different debug session, but it comes down to the same thing as you'll see. So Apple 1 refers to object with ID 22, and the value array contains ID 29. So this is where Apple is stored. Apple 2 refers to the same object, of course, 22, and then Apple 3. A different object, ID 28, but note the presence of value, and we see ID 29. It refers to the same array of characters. So, knowing this, we need to adjust our presentation. Detailed view. So let's redesign our layout using the knowledge acquired from the debug session. The declaration of the first string apple. Apple 1 is of type string and is signed string literal apple. The string is still stored in the string constant pool, but what will be the content of value? In Java, arrays are references, so they too refer to objects on the heap. I'll explain arrays in another video. So value holds an address, namely the address of byte array containing the letters from string literal apple. So this is actually what we have to display. Then Apple 2, same as in a previous layout, it refers to the same string object as Apple 1. And then Apple 3, created using the new keyword. Its content of value refers to the same byte array containing the letters from Apple. So its value reference refers to the same array. And then printing out the values, no difference here. So true for the first one and false for the second one. In the next video, I'll explain the intern method and more advantages of interning strings. But that's it for this demo. See you. Bye.